With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply state a light rod AC of length 2 meter is suspended from the ceiling horizontally by means of two vertical wires of equal length tied to its end. You can see here this is a rod AC and it is tied to two wires. One is a steel and other is made up of brass. One of the wire is made up of steel and is of cross-sectional area 10 to the power minus 3 meter square. This is steel, its cross-section area is this, and the other is of brass of cross-sectional area this much. The position of point D from end A along the rod at which the weight may be hung to produce equal stresses in both the wires is. So we have to strung a weight, we have to hang a weight at D so that equal stresses are produced in steel and brass. Let us now understand what will be the main concept. Let us assume that we are hanging a weight, let us say W at point D, right? So this is your weight which is simply hanging from D. Let us take this distance as distance from the C of this weight as x. Then this distance will be simply nothing but this will be 2 minus x. So if we take this distance as x, then this distance will be simply 2 minus x, because the total length of this rod is simply 2 meters. So x and 2 minus x. Now you can see that as you hung this weight, so there will be some forces which will be produced in the steel wire. Since this weight is simply balanced by, let us say this is force in steel, and let us say that this is simply force produced in brass. So let us call this as FB. Now it is given that we have to find the position of D such that equal stresses is produced in both the wires. So stress which is produced in steel must be equals to stress which is produced in brass. Let us now try to put the values. What is the value of stress here? So the value of stress is simply nothing but force in steel divided by area of steel, and this is nothing but force in brass divided by area of brass. So if you find the ratio of force from here, force in steel divided by force in brass, this is nothing but area of steel divided by area of brass. And we have been given in the question the cross-sectional area. So let us try to put them and let us try to find out the ratio of force Fs divided by Fb. So you can see that the area of steel is simply 10 raised to the power minus 3, and the area of brass is simply 2 into 10 raised to the power minus 3, double. So this will cancel out. So what we get is that this is simply that the force in brass is simply 2 times the force in steel, right? So here the force produced in brass is simply the 2 times the force produced in steel. Now these two forces Fs and Fp will simply balance this downward force. So we can also use the equation that Fb plus Fs has to be equals to W. So from here we can put the value of simply Fs from here, and then we will get Fb plus Fb by 2. This is equals to W. Now you get Fb equals to 3 by 2 Fb equals to W. So from here you can calculate the value of Fb. What is the total force acting in this brass rod in terms of W? This will be simply 2W divided by 3. And similarly, if you put in this equation and you find Fs, that is the force which is produced in steel wire, this should be nothing but this is simply W by 3, and the forces are simply in newtons. Let us take them in Newton. Now this rod has to remain in equilibrium, so let us take the moment about point C. So the net moment of all the forces about point C should be equals to 0, because this rod will simply comes into equilibrium, right? Now MC is simply 0, so you can see that this force produce a moment in simply anti-clockwise, right? So this is simply, we are taking this moment as W into X, and this force will produce a moment in clockwise, so we are taking that as negative. So this is F into the total distance from here to here is nothing but this is 2, and this is force in steel, right? This is simply nothing but this is equals to 0. So from here you can see that this is simply W into X, and this is equals to 2 into force produced in steel. Now from here this is X equals to 2 into force produced in steels in terms of W is simply nothing but W divided by 3. So W will simply cancel out, and you get the value of X equals to 2 by 3 meters, right? So if you take the position from C, it is simply 2 by 3 meters. We can also convert that. This is simply nothing but X equals to 0.67 meter from end C. And if you take the from end A, then what will be the answer? If you take the position from end A, for end A, the position will be simply nothing but 2 minus 0.67, which will give you 1.33 meters. So both can be the answers. If you take the position from end A, the answer will be simply 1.33 meter, and if you take from end C, the answer will be simply 0.67 meter. I hope you understood the entire explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.